I'll show how you can create a reverse shell and exploit it as well. So this is the tool called Huntsman. This tool I have created, which is available on GitHub, whose link I'll provide in the description. So using this, you can create a reverse shell. What a reverse shell is that you spin up a shell which can take input over typically a network. So for demonstrating this is so there are three terminal screen splits you can see. The left one is my local development machine, which is Mac. This one is a Linux machine, uh, which is running Ubuntu, and the below one uh, is Raspberry Pi running Raspbian. So the first idea is that so for exploiting a reverse shell, first thing is that you need to have access to the machine so that you can implant the shell, so that you can create the shell there, to which you'll be providing the commands over the network. So I'll show first that how you can create uh, a binary so that you can inject it to your target. So in this case, since I told you that one of my target is an Ubuntu machine, 64-bit, another one is a Raspbian, which is basically an ARM-based processor, which is 64-bit as well. So I'll use the script called go installer to generate a binary. So it says that you'll have to specify the OS, the architecture, from where you want to compile. Since I'm already in my huntsman directory, so my source I don't need to provide, because by default it takes the current directory. Target is also by default the current directory, but I'll try to create it in some other place. So since I told you that both are Linux machine, one is ARM and another is AMD 64, so I'll create that. So what I'll do is that I'm creating the binary first. My target OS for which I'm compiling is Linux in both the case. For architecture, I can create any. I can use popular. Popular means 32-bit and 64-bit, but since I need ARM as well, so let me create it separately. First of all, I'll create it for ARM. It says that OS is Linux, architecture is ARM, so it should be generated over in the current directory as well. So you can see Linux ARM. I'll do it again, and this time it will be for AMD 64. So you see these two are created. One is Linux AMD 64, one is Linux ARM. So I'll use SCP to send the binary to my target machine. This should be of very small size. Let me see. It's just 8.4 MB in size, and the AMD one is just 9.6 MB. So let me first send it to my Raspberry Pi, which is Linux ARM. My Pi's address is 192.168.0.200, and let me put it in home directory only. First of all, let me show you that what are the contents of my home directory, so that when I execute the command ls over network, you can just match it. So this is my home directory. There are these files. Okay, so if there is any Linux, yeah, it is there, so I'll just remove. There is nothing called Linux. There is nothing like that. So I created it. Now let me send it to where is it at? What is that? I'm not able to send. I've saved it using the name pi. So anyway, it should work. Pi just corresponds to that. Oh, I'm able to send. Anyway, this should work. So the command for SCP is simple SCP, the file that you want to send, the path to it. So it is in my current directory, so there's some. Then, oh, sorry. What I was missing there is that SCP file name. It is so anyway. It should be here already. You see Linux ARM. Yeah, it is there. I'm removing that so that I can show you what was wrong that time, why I was not able to send. So Linux ARM. So the thing is that first of all you need to provide a name, username. So the username in my pi is pi. So it should be pi at the rate the IP address 192.168.0.200. Now the path, I'm sending it to home. Now I'm putting the password, and here you go. So this is the way you'll ideally send. So it is sent. Yeah, Linux ARM is there. Now I need to execute that. So this is just the starting, but since it is kind of a Swiss knife, so you need to provide specific instruction. So here you can see that there is a reverse shell option as well. So if I do reverse shell, then help, you can see it just wants just one thing. It is port on which you want to run. So by default it takes 1337 port, but I can run it on any machine. Let me just run it on 133 whatever 9, anything. You can just put any port, but make sure it is available. Try to make it more 1000, sorry. So yeah, so you can see that it is running. Now I'll need to send instruction. For that we'll be using something called netcat. What is netcat? You can see this is used for benign purposes, but here you will try to exploit. By the way, this reverse shell you can create using netcat as well, but I have written this tool in Go so that it is very fast and concurrent. So the way you'll send commands is you'll do nc IP address, which is 192.168.0.200 in my case, then the port number, which is 1333, what was it, 9. Yes, we are in. Now if you see, I can execute commands and I will get the response. See, initially I showed you that there is Linux ARM file there and anything, so I can do anything I want. Do pwd, yeah, or if you do who am I showing pi. So we have got the access. So the basic concept behind reverse shell is that you spin up a shell to which you send and the standard input is over network and standard output is also over the network, because typically our standard input to a shell is let's say keyboard and output is just the monitor, but in this case the input is also from connection, that is network, and output is also that. So that is the way it typically works. So that's it. This is how you can create a reverse shell and use it. So just use my tool. It is available as open source. If you want, I can also show another example in which I'll do it for Ubuntu. The process is pretty similar. So as you have seen that we have created one for ARM and one for AMD64. We'll be sending AMD64, Linux AMD64 to Sovic@168.0.104, and this one also I'll just send it to home only. If you see my home, relatively new system, so I don't have very much sending it there. I've sent it to my target machine. The binary is sent. Let me run this. It was Linux AMD 64. Again, it is reverse shell. I don't want to specify any port. It will by default run on port 13337. Again, the same thing. NC 192.168.0.104. Then the port not done. 13337. Voila, we have the access. See, we are able to run. Who am I? Thank you. Please go ahead, use it, and let me know the feedback. If you have issues, please file it. Thank you.